Okay, here's the video for graphical transformation. So I'll be able to algebraically and graphically represent translations, reflections, stretches, and shrinks of functions through the use of in-class notes and activities. All right, so let's jump in here. Here we have an equation. Okay, and there's a lot going on in here, but this is each part in here is going to refer to a transformation. But if you look here, really what we have, if we take away all that extra stuff, is we have f of x equals x, and then the only thing that's really happening to x without all this other stuff is that it's being squared. So x squared. All right, so we have the parent function f of x equals x squared, and hopefully we all know what that looks like. So now let's get in here. And I want to first tell you that order matters. Okay, so we're going to want to be following PEMDAS, order of operations, when we do these so that we get the right transformation. So to follow order of operations, we're going to start inside the parentheses. So we're going to start right here, inside the parentheses, and then inside those parentheses, we're going to be doing the multiplying. So this b is being multiplied times x before we do any adding. So this c would happen next. Okay, so we're starting inside the parentheses here. And steps 1 and 2 happen inside the parentheses, and these are all things that happen horizontally. Horizontally. We'll stop with horizontal. All right, so everything that happens to x inside the parentheses affects the function horizontally. Okay, so first thing here, multiply, steps in the order of operation. So I said we're going to start with multiplying. So multiply by plus or minus b. Okay, so look at the plus or minus, so the sign. If it's plus, then there's no change. And as far as the function notation, there's no change. And as far as the points, there's no change. So those would be those would just stay the same. That's pretty much the parent function. We have a positive inside of here right now. However, if we have a negative, so if we were to put a negative right in here, we would have a horizontal reflection, and what that means is over the y-axis. So we're going to look at that in just a second, but the function notation for this would be f of negative x. So we're reflecting over the y-axis. We would denote it as f of negative x, and then what would change is the negative. All the x's would become negative. Okay, so let's take a look at that in Desmos. Here we have our parent function in red. And now if I put a negative in front of that x inside the parentheses, well, it's actually flipping over the y-axis, but you're not really seeing a change here because this is an even function, as opposed to, let's look at an odd function, and I know it's not the one that we had, but just so we can actually see the reflection. Put a negative here, and now we can see, let's get rid of these guys. Here was our original in purple, and here is our new one in red. Okay, so that is the sign on the b. Now we're going to actually look at the b itself. And if b is a number that is greater than 1, then we have a horizontal shrink. We have a horizontal shrink, which is going to make it skinnier. And I'm going to fill in this next part, look at it in Desmos, and then I'll tell you the notation. So if b is greater than 1, we have a horizontal shrink. If b is greater than 0, but less than 1, and notice I'm saying, oops, b, that's a b. We're saying greater than 0 because we're not talking about negatives. We already covered this up here. So we're talking about a fraction between 0 and 1. Then we have a horizontal stretch, making the parabola or whatever the parent function that we're looking at fatter. So let's take a look at that in Desmos here. Okay, here's our parent function, graphed, x squared. And now I'm going to put inside the parentheses, because that's what we're working on right now, a number greater than 1, like 2, and see what that looks like. So you can see that this is a horizontal shrink. So it's being shrunk horizontally. It's being pushed in on either side. As opposed to if I put a fraction here, I'm going to get a horizontal stretch. So it's being stretched out horizontally. Okay, so now let's put the notation in here. This would be if we're using the number 2, we would say f of 2x for a number that's greater than 1, and we could use for a fraction, I'm just going to use 1/2. So this is what the function notation would look like. What would actually happen to those points, so all the points on the graph would go from x, y to all the x's would be divided by 2, and the y's would stay the same. In this case, all the x's would be multiplied by 2, and the y's would stay the same. So you're actually seeing the opposite here, and we're going to make a little note about that out here in just a moment. But actually the opposite's occurring from what you would think. When I have a number greater than 1, it's actually shrinking horizontally, and I'm taking all my x's and dividing by 2. Okay, so coming down here, we're now going to look at, let me highlight this for you. So this is the part that we've dealt with so far in orange. Now we're going to look at C. So add or subtract C. Okay, so now we're looking at this. We're still inside the parentheses, so it's still going to affect it horizontally. So look at the sign on C, or of C. Okay, so if we are adding C, then we're going to go to the left C number of spots. If we are subtracting C, we're going to go to the right C number of spots. Okay, so let's take a look at that in Desmos. But here we have, I'm going to get rid of these guys. Here we have our parent functions. If I add, here, let's say 3, we actually move to the left, and if we subtract 3, we move to the right. Okay, so coming here, in our function notation, we would have f of x plus c, because that's what's happening. However, what's kind of maybe confusing or tricky here is that all the x's are actually going to move to the right that number of spaces. And you know what? I didn't mean to put c here. I meant to put the number, a number that we're going to use. So in this case, since I showed you in the notes, or in Desmos 3, let's do 3 here. So the function notation would say inside the parentheses we're adding 3, and you would see it here as well. But what's actually happening is all the x values we would subtract 3, and nothing would happen to the y. Here we're going to subtract 3 in the function notation. You would also see that right here. But what's actually happening to all the x's is we're adding 3 to all the x's because we end up moving to the right. Okay, so we've covered horizontal, and maybe you noticed kind of a little bit of a pattern here, but for everything that happened from here to here, it was kind of the opposite of what you're expecting, right? When the number is bigger, you actually shrank and you had to divide by the number. When the number was a fraction, you actually multiplied by the reciprocal. Down here, when you added 3, you actually subtracted 3 from all the x values, and when you subtracted 3 inside the function, you actually added 3 to all the x values. So from here to there, we're going to make a little note. It says, because I know it's not very clear here, it says in parentheses opposite. So in parentheses opposite, maybe you have more room, you can write it out nice big up here. Whatever is going to help you remember, these are your notes. But when we're inside the parentheses, we're talking about changing the graph horizontally, and we end up doing the opposite of what we actually expect. Okay, coming down here. So now we're looking at what's outside the parentheses. So we're going to start with the multiplying again, because that's order of operations, and then we're going to go to our add. So we're going to do this, and then we're going to do this, and all of this is going to affect the function vertically. So we'll just put vertical out here for these next 2 steps. Get your L in there if you can fit it. Okay, so now let's take a look. We're going to start with multiplying. So we're looking right here. Multiply by plus or minus a. And first we're going to look at the sign, so just like we did above. And if it's plus, well, no change. So this stays the same, this stays the same. But when it's a negative out front here, we have a vertical reflection. This is really small, and I can't write that small with this, but hopefully you can fit it all in. A vertical reflection, and then I just wanted to add on there, that means it's over the x-axis, so that way you're nice and clear on that. Okay, so for the notation now, before we were inside the parentheses, now we're going to be outside of the function here. So negative f of x. And how does that affect the x's and y's? Well, all the x's will stay the same, but all the y's will now become negative. And so that makes sense, because if you remember back, f of x, well, we used to write equations with y, then we eventually wrote equations with f of x, and now we're saying negative f of x means negative y. Okay, next part here. Then we're going to look at the a. So if we have a that is greater than 1, we will have, get my arrow, a vertical stretch. And if I have an a that is greater than 0 but less than 1, so we're talking about a fraction, not a negative, then we're going to have a vertical shrink. Okay, so let's go back to Desmos and see what that looks like. Here's our parent function here, and now I've put 1/2, so a number that's between 0 and 1 onto this. You know what? I meant to put it on the outside. Let me fix it. There we go. 1/2 is on the outside now. So we have a vertical shrink, meaning we're going to squish it down this way. When we squish it down this way, it kind of gets fatter there. And then for this, when we multiply by 2, we're going to have a vertical stretch here. So it's actually being pulled up vertically. Okay, and so what does that notation look like? Well, we would have, just to give it a number here, 2 f of x. And what that means is we're going to multiply a 2 on all the y's. The x's are going to stay the same. We're going to multiply all the y's by 2. Remember, back here, it's opposite, so we ended up dividing. But here we're going to do exactly what it is, so we multiply by 2. Here I'm going to put a 1/2 out front times f of x. So this becomes x, and then 1/2 y. So exactly what you're expecting there. All right, last transformation we're going to look at here is this one over here, so the d. So we're looking at what happens when we add or subtract d. So we want to look at the sign of d. And if we are adding d, then we're going up, because remember we're talking about vertical, d number of spaces. And if we're subtracting d, we're going to go down d number of spaces. And I think we're actually pretty familiar with that, so I'm going to skip over the Desmos version of that, because we've already kind of looked at that when we were looking at the 12 basic functions. So now we're taking the function and we are adding, let's put a number on here, so 3, or we're taking the function and we are subtracting 3. And because we're talking about the vertical and we're talking about outside the parentheses, what we expect to happen is going to happen. So what's going to happen is we're going to take all of our y's, f of x is y, and we're going to add 3. So my x stays the same and my y's all get 3 more on there. So it moves them up, if you can picture that. And now my y's all get 3 taken away, and so my whole function moves down. All right, so up here it was opposite, so down here from this point we're going to write outside of parentheses same, or I'm going to try to squish it into that small space right there, and you can add it wherever in your notes, but that way, any way that you'll remember it. Okay, so that was poorly written. Hopefully that makes sense to you, that this is the opposite and this isn't exactly the same, because we are doing some transformations, but it's basically what you're expecting to happen happens. Okay, coming to the back here, I do want to point out something very important. A special note about the horizontal translations. Here our parent function is just the absolute value of x, And it would appear, and then we have some things going on with it. So it would appear that the transformations are horizontal shrink by 2, because we're inside here, not inside the parentheses, but we're inside the absolute value symbols. So a horizontal shrink by 2, so the opposite of what you would think, and then a horizontal shift left by 8 units. However, in a case like this, to see the actual horizontal shift, we must first factor out the stretch or the shrink. So factor out the stretch slash shrink, and I say slash because it's one or the other. We just don't know which one yet until we see the problem. Okay, this would make f of x, so we're going to factor it out. I'm still going to have my absolute value signs, but I can pull out a 2 from the 2x, and I can also pull out a 2 from the 8. So now I have 2 and then x plus 4, like that. So this changes our transformation. We're still going to have a horizontal shrink by 2. Or better yet, really by 1/2, because keep in mind it's the opposite. And then we're going to move left four. So I'm realizing now, and I'm sorry about this, I'm realizing now it doesn't always work for it's the parentheses. I should say inside the function here. So when we're inside the function, it's the opposite. When we're outside, it's the same. And this will make more sense once we actually get into some problems here. But when it's applying directly to the x, it's the opposite. And when it's applying to the whole function, it's the same. So sorry if that's confusing. We'll clear it up soon enough. But let's take a look at what this function looks like. Okay, here's our parent function, the absolute value of x. And we thought by looking at this that we were going to actually move left 8, just by looking at this. But then we decided, or that we figured out, that we actually need to factor this to find out where we're actually moving and how far. Okay, so if I turn this one on, you will see that, let's turn this one on. We're actually moving over by 4. And whether you factor this or not, this function is still going to behave as it should. It's just you need to factor it to see where it's going to move. So when I go to click on this, it's in the same spot. So you see that this is not actually moving to the left 8, it's moving by 4. And so to make sure that we do this correctly algebraically, we need to factor out that 2. Okay, coming back, let's try a couple problems, and we'll do some problems like this in class to make sure we're all clear on having to factor first. And if you want to, I would maybe even make a note, factor first. Okay, so factor first and then figure out the transformations. Okay, so what's happening here? We need to write these in the order that they are happening. So we are going to follow order of operations and start inside the parentheses and see if there's any multiplying. Well, there isn't anything happening to the x. So now the adding, the +3 is actually doing the opposite of what we think it's going to do, and it's affecting it horizontally. So we're going to move left 3. All right, number 2. We're done inside the parentheses, so now we're going to move on the outside the parentheses, and we need to start by multiplying. So what is this guy doing up front here? Well, if you need to, flip back to the page before and look at the notes. But this negative outside the parentheses, or outside of, it's not happening directly to the x, but happening to the x squared. What's happening here is we are going to flip over x, which is a vertical reflection. Okay, so we've taken care of this. We've taken care of this last right here. It's still outside, so I know it's going to affect this function vertically. So number 3, we are going to move down 5. Okay, there we go. Oh, I did not write the parent function. I meant to do that at the beginning. So write the parent function. Make sure you do that. So the parent function is f of x equals x squared. And I put the parentheses on here because it's going to make more sense as we go through our transformations. Okay, coming over here, let's start off by writing the parent function. So the parent function for this one would be the square root of x. So we have f of x equals the square root of x. And now we're seeing what's happening. And before, when I was talking about inside the parentheses and outside the parentheses, we're talking about underneath the radical sign. Okay, so underneath the radical sign, what's happening first? Well, we need to multiply first. So number one, we have a negative. So we're going to flip over the y-axis, also known as a horizontal reflection. Okay, number two, now we have some adding going on in here, and because it is inside of this, it's happening directly to the x. We know it's going to be the opposite. We also know it's going to affect it horizontally. So it's going to move left by 3. And then lastly, outside of the radical, right here, we're going to, we know it's going to be vertical, and it's not going to be the opposite. It's going to be exactly what we're expecting. So up 1. Okay, there we go. There are some couple worked out for you. Now go ahead and try these, and I just want to show you on each of these. Now we're talking about what's inside the parentheses as opposed to what's outside over here. And here we're talking about what's inside the absolute value symbols as opposed to what's outside of them. And we'll look at the other parent functions as well in class and see what's inside and what's outside. All right, thanks for watching.